Here it goes. Hi, welcome to Coffee Compiler Club. Anything to do with compilers and language runtimes and null pointers and typing systems and language implementations of all kinds is fair game. It's an open mic, ask what you want. I don't have a set agenda. Conversation typically rambles or being videotaped. You'll all be up on YouTube videos within a couple hours. That's it. I think everyone here has been here a bunch of times. That GIF is killing my CPU. Oh, is this my self view being too ugly to look at?
No, if you look at the Google Doc, you'll know.
Oh, I didn't look at Google Docs because
I'm joking. It's not killing my CPU.
Oh, there it is. Yeah, that one's brutal to stare at on a continuous basis. I don't know if I want it moving. Yeah, kind of fun. I keep trying to figure out how to easily click my way into getting it onto the front or the tail end of the video, but near as I can tell, YouTube doesn't have a way to put an animated GIF just as a cut and pasty thing. So I'd have to take the video into a video editor and throw the animated GIF on and then upload it to YouTube. I'm like,
just make it your Zoom virtual background. You'll be all set.
Oh, that'll kill people. Having it moving. I get the non-moving version. That wouldn't be so brutally bad. So here it is. I can't see myself because I hid my self view. Now I don't have to unsee my self view. I have to admit York. This is my t-shirt, right? So is there a way to God, how do I undo my self view? Can people see the t-shirt?
Yep.
This is swag time.
Yep.
Oh, and York made it back. Okay, good. So if send me an email if you're interested. If I get a quorum, I think I asked a year ago. If I get a quorum at say $20 a pop, I'll go make a bunch of t-shirts and send them around to folks.
I will have to wait for mine. Like,
well, you know, whatever fast the mail system works. I don't know how quick or slow that goes.
Okay.
Here I can redo my video.
I bet everything
I
is faster than
my self view now.
I bet everything is faster than sending a package to Vietnam. That took about 3 months.
We should split it up between the distributing it in the US and Europe and Asia and Africa.
Well,
Like-
it was super interesting. Germany to Japan was like 2 days, and then it stuck in nowhere for, I don't know, like 2 months or so.
I don't know how many continents we have Coffee Compiler Club members from.
Now is the time to find out.
So anyhow, if you're interested, you have to send me a mail and say I'll pay $20. If I hit a quorum, I'll run a bunch of t-shirts. And if I don't, then you know, no harm, no foul. And since there's only like a dozen people here today, it's probably not a quorum already, but maybe some more folks show up here. New York, you're in. I have the AA run up, right? The AA whatever news. I actually had real life interfere. Actually, I'll say that first. My real life interfere. So my daughter is driving at night in Davis, outside the California countryside, stops at a stop sign, and gets rear-ended at 50 miles an hour at least by a lady in a sub. She like no brakes, no skid marks. She was staring at her phone. Plowed into my daughter at high speed. She's fine. She's beaten up. It's like, you know, you get worked over by thugs in a dark alley. But she's, you know, getting better from being beaten up. Like she's got one twisted knee that might be a little bit longer. Her car is completely totaled, and I spent several days this last week sorting that out. So I got her a replacement vehicle and made sure she's got health care and whatever it takes.
Yeah, the cars have gotten pretty good at dying to make sure the driver doesn't.
It's a rear end, not a front end, so it was a little worse than normal, but it was, you know, it was a Prius. It folded up like an accordion, sure enough. But her knee got caught, her foot got caught on something, and the knee hit the dash and went sideways. So she looks all ugly on the knee and is walking around on crutches. But doctors say nothing broke. Cartilage tissue damage should repair. Might be another month, but should be fine.
Sorry to hear that. Send our well wishes from the club.
Yeah, I can do that.
Yep.
It happens. The other thing is that I talked last week, probably the week before, about approximating types. I have kind of worked my way around to believing that it can't actually be done. I have some interesting counterexamples that are difficult to approximate with the properties I listed last month, where everything's an is-a relationship going on, and it's actually shorter as well. And I can come up with types for which there's always somebody else who's in between one or the other of your approximation and your original value. Like the dividing line shrinks asymptotically, but never hits 0. So somebody can be in between that doesn't need an approximation. That blows monotonicity because the guy who approximates falls and the guy who's in between does not, and you blow monotonicity. So I don't know if that's required or always there or whatever, but I certainly find a lot of examples in my testing, and various attempts I've made at going around it have failed. And I finally proven certain cases it definitely can't work. Some cases it definitely can, but I don't have a general theory left or right that it can or cannot. So retreating and approaching the problem from a different angle.
Do you have a small example where it clearly cannot be done?
Yeah, I was working out the giant docs of how to write up, basically a month's worth of what the fail is here. Let me throw this giant comment into the doc, and then I'll clean it up as an example here. Where's a comment here? Not a block for copy. Yeah, it's a code block. So here's a code block. You want the comment that has some texty looking things with bad spacing because somebody tabbed me versus I don't want a tab, I want a space. I'm trying to make an ASCII table. Okay, so see the lines that says T0 equal or T1 colon, yada, yada, yada. So T0, and then you can read what I'm doing and why I believe it does or does not work. So T0 has a alias number 2 pointer. It's all the same alias number, so it doesn't matter. It has a pointer to a struct with field 0 and field 1. The high value means something that's above the center line and can fall to less and less information until you know nothing about what you got. Mediums are somewhere in the middle. It's the center line of a constant. Low be bottom and other lingos. Depends on whether you're inverted your lattice or not. So the T0 has this funny thing. It has 2 instances of the alias, and I want to approximate it to get it back to 1. And field 0 is high. Field 1 is a pointer to the second instance. Within this, field 0 is low, and field 1 is some high value. And this kind of a type shows up all the time while I'm starting the lattice at the highest value and starting the typing system at the highest value and relaxing the typing system down to finding the best answer out of the flow types. Standard constant propagation algorithm. T1 has some medium for F0, has a low below any pointer for F1. So T0 is a T1. I do it with double right arrows and the comment right below. We can see that T0 greater T1. So there's an is-a relationship there. Going from left to right between the T and the approx versions, I'm going to talk about number 1 first because it's easier. There's only 1 instance of the alias. I do nothing for the approx. So T1 is a AX1 by totally trivialness. When I look at T0 to go to AX0 and I want it to be shorter, so only 1 instance of the alias too. But I want to know that all paths I can walk through the structure T0 are at or below their current values in the approximation versus the original T0. So here I can make a cycle because the nested F1 is high. So looking at these 2 guys, T0 and AX0, I don't point with my fingers on the screen here. I can walk paths to say, I have, for 2 guys, I have both pointers to alias, to a struct, to an F0 first. High, it beats low, so that part is a relationship. Then I go to F1 and F1, and I have a pointer to a struct, and the other guy is the nested copy of F1 is high, and that says that I am, the nested guy is higher than the pointer, and therefore I can close a cycle. When I close it and do the cycle thing, I'm going to say the cycle value comes around, the both of them are pointers to F. The first pass of the cycle, both of our F1s are pointers to struct, to whatever. The second round of F1 has a high value on the left, has a pointer on the right. So it also is a relationship despite the cycle or with the cycle. So I have a cycle going from left to right on T0 to AX0 and an is a relationship going from T1 to AX1, is a from T0 to AX0. But AX0 is not AX1 because AX0.F0 is low, AX1.F0 is above it. It's not below it, not tied or below. So it fails to be an is a relationship going that way. That version of approximation is the one where I try to get a cycle out by effectively taking the second instance and moving it into the first. I got a, what? Hang on.
We can share a screen if
Sorry.
we.
Yeah, okay, I can do, but I can't highlight both. Let me do share screen here, but I can highlight, but I don't know the help, but we'll do that. We'll just, this is, no, a bunch of people showed up while I'm yakking. I can't go to shared options. Let me add people and I'll share in a second here. It's Max and Art. I'll write myself a note. I'll do the other stuff in a minute. Okay, so let me go back to hitting the share screen button. Share. Hi guys. Okay, so I'm looking at this set of lines. T0 is an AX0, T1 is an AX1. AX0 has the property, it has only one instance of alias 2. I'm repeating that for the two new guys. So there's only, so it is an approximation. T0 is a T1, but AX0 is not an AX1. So does that make sense before I go on to the next step here? Like more or less. Having shared screens, I can't see anyone's video, so you have to say.
What's a one-sentence explanation of what's going on right now?
So I'm trying to show that I'm trying to approximate types. So the real problem here is that during the partial evaluation of forward flow analysis for doing types, same as it's a glorified constant propagation, greatly expanded in all directions. When I run across the computing the constant value for a new struct, someone says new person object, whatever. You wrap a person object around your fields, the type of the person object is wrapped around the type of the fields, and you get a new type out, which is a person pointer with types of those fields. If you put this in a loop, you keep wrapping person on person on person on person, it never terminates. You get an endlessly increasing linked list. Okay, so to force termination, I need to approximate at some point. And my theory had been that I can approximate by basically counting numbers of times I see particular alias. So in the example here, it's alias number 2 is the stand-in for a person. And when I see too many, I'm going to do something to make a new version that is shorter, has fewer aliases of number 2, perhaps by making a cyclic type, perhaps by chopping it off to like scalar or some very low value, or scalar or low or synonymous. It means below any pointer, and I lose the knowledge that I had a pointer here in the first place. Maybe I'm mixing floats and ints and pointers and I have no freaking clue. It's a Java object or something. It's a really low value. Okay. So in the example here, I've highlighted, I don't know if it shows up in your Google Docs. T0 is a AX0. That's the exciting approximation. T1 is an AX1 because trivially there's only one instance of alias 2, so there's no change needed. T0 is a T1 because all the fields that correspond are tied or below. But AX0 is not an AX1. I lose monotonicity in this version of approximation. And I can get this type, this broken type, by doing what I call a meet uphill. I take the second or the deeper nested instance of alias number 2, and I map it over the top instance, and I change the nested guy to a cycle pointer. So all the non-F1 fields, the fields not involved in the cycle, all get a meet from the low guys to the high guys. And the end result is an approximation that has the properties that, you know, it matches the is a relationship. another way to view the is relationship here is that any path I walk through a series of loads and field accesses in either the original type or the approximation have the property that they're always an is-a at every step along the way.
I believe we should mention that is-a here, according at least to me, the is-a T1 and AX0, this means structurally. Can we approximate the two structures T0 and AX0 such that we come up with a structure that approximates or generalizes the both structure?
Yeah, it's generalizing the original structure. So that goes to my property number 2 listed above. It is self-monotonic. T is a T.approx.
So our problem would comes how to approximate F1 on the T0 and the AX0 F1 field respectively.
Yeah.
Okay.
So this version has the problem that you see here that this is the subtle version of it. I also attempted,
Why do we fall all the way from high to low rather than stopping at mid briefly?
for F0?
Yeah, I feel like F0, you should need 2 calls to approx to get all the way to low.
Right. Okay. So the approximation is shorter, has fewer bits to it. That's the goal. If I were to I have a program that walked T0 by doing fetch field F1, fetch field F0, it gets a low value. That monotonically can't ever lift. Always I have to be able to say, given a pointer, go .f1, .f0, you hit a low value. If I let it rise, I lose monotonicity. This means I lose termination. I lose the greatest upper bound or greatest lower bound, or however you want to look at it. I lose the property of a fixed point with the best answer. So if I look at the approximation and I go F1, that cycles me to F0, I get a low. If instead I had a medium there, the path, pointer.f1.f0 would be medium. That is strictly higher than the same path on T0 .f1.f0, which is low, and I lose monotonicity. So you must meet the low bits and the deeper nested bits with the shallower bits to get a valid approximation. So is that answer you good now? More or less clear as mud?
I guess my question is, if it stopped at mid instead of stopping at low, it sounds like this would solve the problem. Is that not true?
No, it loses property number 2 then. So I'm going to go edit mid here briefly. So if I made the property that it was this has the failing that it loses property number 2. It is not self-monotonic. T0 is an approx 0. And I give you a counterexample of following the path .f1, .f0, roll backwards. It had been .f1, .f0 hit low, now .f1, .f0 hits medium, it rolls backwards.
I see.
Okay. So the rolling uphill is not allowed unless the deeper guy is strictly less than or equal to the upper guy and all the non-cyclic fields. If they is of the reverse direction, you're valid, you can do it. So having with that notion in mind, I said, well, what if there is the other way? The upper guys are always high in the lattice, and as you go deeper and deeper into passing aliases 2, you keep going down and down and down in the lattice. Eventually you must terminate. The lattice is finite, you'll hit bottom. Okay, that shows up down in now comment the next page down where I say another attempt I tried is to meet downhill, or to meet from a shallower alias to a deeper alias. And I got a functioning version that met properties 2, 3, and 4. That is to say, it was it was monotonic for the case that's failing in the meet uphill. But I can actually very easy make a test case where I get ties instead of strictly downhill, and I get an endless sequence of tide values that just run across and say, it's a int 8 with a pointer to a linked list. It's got an int 8 with a pointer to, and then a payload field with an int 8 pointer to, and I have a for loop that says for I equals 1 to n, make a new linked list where the count is I, and you link your list. The 2-line program here I'll throw in that shows the fail here. That's I equals 0, I less than n, I plus link is equal to new link of I and the old link. So we'll call, I don't want link here, I want L, which is, I'll call LK. So geez, quit that. No caps. Yeah, something like this. And actually make this a little easier. Link LK equals null. So here's some C-like code that says, have a linked list structure. It takes an integer, which it just puts in a payload field and a next element of the linked list. If I do partial evaluation of this, and I'm looking for a fixed point, LK starts null. Then it becomes a pointer to an alias with a count of 0 and a null, and then it becomes pointer to an alias with a 1 and a pointer to a null, except that now I want to approximate, and I get count goes to 1, whatever, and the link goes to nil or another link, self-link, which I'm trying to get. But then as I keep running round and round doing this meet downhill property, I get an endless sequence of the next link you get out is prepended always with a new, extended with a new instance of link, and the tail is always an endless series of an int 8s down to a cycle at some point, but I get an endless sequence of links. I don't ever roll up to a cycle. So that property failed the doesn't grow indefinitely version of things. And I tried various versions of chop, which quickly lead to the failed property number 4, because somebody accidentally gets a hair below the chop depth, gets cut off, then he lost some information that he never recovers, but he propagates his lossage, his confusion to everyone, and everyone else quickly loses everything as well. So I've been at this for about a month, and I have several versions of Approx that fail on several test cases. I have a bunch of test cases as well. I have a bunch of cases where, some of these things work reasonably also, but I haven't been able to find an algorithm choice that didn't lead to some kind of fail. So what I've done here so far is I've shown you meet uphill, meet downhill, and chop. And one of the other observations I have is any attempt that involves a chop-like effect, like a hard cut to a particular low value, usually blows property number 4, you get ugly fast, or it blows monotonicity because you chopped somebody too far below and somebody else didn't need to be chopped, and you fell above to below and you lost, just like the first example I gave there, you lost monotonicity. So to avoid losing monotonicity, you have to chop sort of trivial people off. And suddenly you get to answer number 4, which is everyone gets chopped off right away, and you suck for an answer.
Well, the answer is obviously to use AI, so you can differentiate those two.
I'm sorry, use AI? Yes. Yes, clearly.
It might increase the number of bits, though, slightly.
Yeah, right. So I have, not attempted yet down below the next where I'm headed from here. Hotspot for integers use this widening notion, which is equivalent to a chop below some point. But instead of chopping at where I say new linked list, I chop at the meet operator, which essentially means I disallow in the system types of arbitrary complexity unless they have a widening count that's low. As soon as the widening count gets big, they are no longer allowed to be arbitrarily complicated, and the type system itself essentially like whacks you off pretty harshly there. And so that one probably works. So meet and ISA is defined by meet. Sorry, ISA is defined by meet. So as soon as meet says, I understand how to chop off complicated things because of widening, the is a problem gets solved. That's what happens in hotspot for the integer ranges, where I say you have a range from 0 to 1, 0 to 2, 0 to 3, 0 to 4, and then I'm like, stop the range thing. And, at some point I say widen too many times, chop you to int 64, and you're done. That might work. In the land of sort of Hindley-Milner style lambda calculus, the meet operator shows up at recursive function calls. So it shows up at arguments to lambdas, but it's the same thing. There is a meet point and it's an obvious loop head. It's just a recursive loop instead of a classical C for loop. There's another version floating around where I arbitrarily don't define the types of the program point that does a struct, like the new link in my little example there. And instead I say, if you ask for a links field, you just go to the point where the link is defined and get the field content directly. And that avoids me trying to type the linked list going infinitely. And what it basically amounts to is you only ever have one alias instance for alias number 2 for the link or the person object. You only have one of them. You can't define any fine-grained structure of nested persons. There, you lose all that, but maybe that's okay. So in that version of things, type T0 is disallowed in the first place. You never shows up because you don't have a nested version. You only ever get alias 2s, only one of them ever exists, and you just approximate everybody into the same file. So one of those two is probably where I need to go next. Suck. Mostly suck for burning a month to get here, but I think that's where I'm at.
In your second solution, it's each alias point that would just recurse back to an alias point, or each type?
Okay, so when you say second solution, you mean the meet downhill version or the meet uphill version? Meet downhill?
Yeah, I was thinking the meet downhill version.
Yeah, okay. So
You said you solve your recursion by each alias point simply has to be a type, and when I widen one, I've widened all.
yes,
Those are only the aliases, not every instance of that type.
Well, those two are almost synonymous. They're not quite. I can have pointers that have confused with other pointers or have nil or not. And then I have different instances of a struct. So as soon as I say I only allow one instance of a struct, type T0 goes away. In the meet downhill version of things, the goal was to say the types always run downhill, even if I have multiple instances, but they strictly run downhill. Therefore, the list terminates, the type complexity terminates, and I'm okay. In what you just said, it's not really meet downhill anymore. It's just every time I see an alias 2, I meet it with all other instances of alias 2. And there's only one version of it. That's what I'm talking about when I go to the not attempted yet, the HM theory only uses simple pointers flavor. So there's no, you don't get any complexity of there are multiple instances of alias 2 that have different things that I know about them.
So that has definitely broadened the things you can type, but weakens the things your type system can tell you.
Yeah, I have to reach a point where I'm not either running infinitely or running downhill, or I don't type at all. So as soon as I say I am terminating, what can I learn? Well, I would like to learn that a pointer is nil or not, and it would be commonly the case that I'm holding in my hand a pointer which is not nil. It points to a struct which has a linked list which may be nil. So not all pointers to link objects are nilled, because I could have one in my hand that is not nil. So I want to say pointers to link objects can have the property that they're nillable or not, but the link object itself, all fields within it have all been approximated to each other. So if I have a linked list that alternates between throwing in ints and strings, I'll lose that precision. If I have a version of a JSON object description, a DOM-like thing where I parse some JSON into some local AA structs, all JSON objects will look alike. I cannot tell them apart because they all will be approximated the same way. and you lose the precision that you might otherwise get. So in the case of a JSON guy, the baked in original type system would not be able to read a JSON object and produce a DOM that was JSON-like that had that type in the type inferencing. It would only be able to do that at a user level typing additions. Or if you did some sort of reflection thing where you made new instances of new class of objects, new prototype objects for every new JSON thing that came around, then you could get your precision back. This is a non-trivial meta typing thing now. Which, you know, maybe that's just fine. That's the state of the universe anyhow. You can't do what I just said normally anyhow, so fine.
So if you had a structure that went straight for a while and then had a loop in it,
Yeah.
can you express that in your types that you're telling the developer?
Right. So as it stands,
A
right
can
now-
contain a B, can contain a C, but
Yeah.
C's only contain D's, D's only contain C's. So it starts looping CD, 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 but it's A, B, CD, CD,
Okay,
CD,
as soon as
CD,
you have
CD.
different alias types that only show up once, I'm okay with that. So that's a type that says an A contains a field which points to a B, which contains a field which points to a C, which contains a field which points to a D. That's all perfectly precise as it stands right now. That's very standard in anyone's programming language. A person has a name field, which is a string, which is a bunch of cars. Person has a zip code, which is an integer thing. Person has a employer, which is a whatever it's going to be, right? So you can have nested objects of unrelated types, but as soon as you say C points to a D and D points to a C, one of the approximations has to eventually say all C's point to all D's point to all C's, but A's and B's are still separate.
That sounds like what I would expect.
Yeah, it's what you'd expect. Yeah, there's no question about that. The question is, can I say this particular C instance knows something smart before I wrap around and found another version of a C that I know something differently smart about? As soon as I say all C's look alike, this problem goes away. So I was attempting to say, basically I was attempting to say, if you chase through pointers, I know something strong about the nested deep, the structure of your memory. I know something about the structure of your memory. Can I at least know that you have cycles? I think I can reach a point where I know that you have cycles of basically length 1, but never cycles of length more than 1. And maybe that's okay. Basically, I was trying to get too aggressive on what I could tell and still be monotonic and terminate reasonably and all that. And it looked good because I had a bunch of cases that I could work it out on that worked just fine. And then I kept finding counterexamples. So eventually I reached this point where I burned a month and decided it's not going to work.
So if you just say all C's are the same, you've given up some knowledge about the world.
Yeah.
But I don't think you've given up the ability to be forward compatible with something that eventually gets smarter about that, right?
Well,
Or
right.
once you decide that, have you decided that kind of forever?
Once you get to generalized C, it's hard to come back to something more precise because
Well, this is why I'm mixing in Hindley-Milner, because exactly what it does is it will tease apart that situation. So I have a blended Hindley-Milner and forward flow typing. If I let my forward flow get stupid in places by claiming that all alias 2s are the same, for instance, Hindley-Milner might come along and say, and at this point, I know for a fact that this is a person who's actually a Canadian versus a person who's typed as a American versus whatever, and he'll bring me back some knowledge about what it is, where I have otherwise given up and said, all persons look alike. And say, no, I can tell them apart. So it's not, I give it up in the flow system, I get it back from Hindley-Milner, and he puts it back into the flow side. Like the two type systems interplay. This was just what I can do in flow alone without bringing in Hindley-Milner. I can totally bring in Hindley-Milner. I do totally bring in Hindley-Milner. So I get some of this back because of that. So maybe I don't care. I can lose precision here. It's okay. I get it back later.
Hey, can I ask a question? Sorry, I was running out in and out of the house. I didn't quite follow, but I'm just curious, where is the cycle coming from? Is it coming from parameterized types or?
No. So,
Wait,
so
follow me.
you're talking about the cycle. I'm highlighting. I don't know if you can see the highlight on
Yeah.
T0 is a blah, blah, blah. Okay. So this is me creating an approximation type because I don't want my T0s to grow without bounds.
Mhm.
If that would help you, the T0 type is not typed. The Hindley-Milner has to recognize the type. What
I haven't talked to Hindley Milner here at all.
Mhm.
The T0, he's asking where the cycle comes from.
Mhm.
The problem I have is that if I'm doing essentially partial evaluation on the type lattice to try to achieve a fixed point solution for flow types, ignore Hindley Milner, just on flow types alone. When I run through a loop that's adding a new linked object of alias class 2, I'll grow endlessly alias class 2 objects in my typing system. I'll get an ever longer. So I have to approximate to chop it off.
I see.
Okay, here in this example, basically F1 is being used as a link field, point to the next instance of an alias 2 guy. My little tiny for loop on the next page down, it's like 10 lines down, shows an example where I just nest linked lists indefinitely, doing partial evaluation. At some point, I need to take the approximation I have, take the type I have and approximate it. And I want to be able to say I have a cycle in the type system.
Mhm.
So my type system, the coding involved totally supports cycles and understands how to deal with cycle-like things. I just have to declare at some point the approximation produces a cycle. I also want my properties 1, 2, 3, 4 right above my comment where I say CNC and a date, where it is a relationship. It is a monotonic across, T0, T1, and it is monotonic from T0 to AX0, and it shrinks and it doesn't suck. Okay, so going from T0 to AX0, it's monotonic and it's shrunk. And to do that, I made it cyclic. To shrink it, I made it cyclic. So that rolls up the infinite tail of alias class 2s that are repeating ad nauseum. I rolled them all up and made a cycle. So there's an algorithm that chooses when to do that and how to do that. And that's one discussion. But the typing theory side of it is it's an approximation. It's done with a cycle that makes you strictly shorter than the infinite list.
Right.
It's monotonic by taking all the F0 fields and meeting them all together, however many there are in the linked list. I only showed 2. Suppose the linked list had 200, 2 million. I meet them all together. Now the approximation is strictly lower every step along the F0s, and it's strictly lower at the cycle, at the pointer to 2, because the self cycle is always a pointer to a 2 anyhow. So it is a relationship, and it's short, and it's doesn't suck. It gives me a nice type, and it blows property number 3. And I give a counterexample where I blow property number 3.
Okay, so is when you say approximation, is it like a more general type that is of that type also?
Yeah, it's a more general type.
Approximation, you make a more general type.
Yeah. So here's a version using integers only that's maybe it's easier to understand.
Yeah.
Suppose I have a for loop and I'm asking what is the type of I, and for I equals 0 to n. Well, in my usual forward flow constant propagation algorithm, I starts 0.
Yes. Okay.
Then I loop around, I add 1. And then at the phi function at the head of the loop, I meet a 0 with a 1. Now, what is that value? Well, I decide to have an integer range from 0 to 1.
Okay.
And I take the integer range through and I add 1 to it, becomes 0 to 2, and I meet it back to the original phi function. I have a 0 to 1, I have a 0 to 2. I meet the 2, say it's 0 to 2, but I didn't terminate yet because the type changed. So I go again. Now it becomes 0 to 3, 0 to 4, 0 to 5, 0 to 6. Okay, 0 to 2 billion. I'm not waiting that long. Right? How do I stop this? At some point, I approximate it.
Yeah.
By declaring it, whack, you're just an integer now, I'm done. And 1 added to an integer is still an integer, and I'm done.
Okay.
So I have to have morally the same effect. I keep prepending a new linked list object. I need the types to stop at some point, quit growing.
Yep. So is your type system an actual lattice that there's always a join and a meet?
Yes.
Like just the
Yes, it's a complete lattice. It has a join and a meet.
Well, there is a general type.
And there is a general type. Yes.
Sometimes it would take too long to get there.
Yes.
Maybe
so I want it to be bounded.
Yeah. Okay. All right.
And it's sometimes called ranked.
Interesting.
It's complete, it's symmetric. It has like 5 other properties. I have a list of them. Officially, you can go look them up on Wikipedia, what they each mean.
Yeah, so just you count and certain after a certain number of times you hop up to int. Is that
Right,
what
right.
yeah.
So that's how the int one widens.
Yeah.
So I was trying a different version of widening here, where I said I would allow so many instances of an alias in a given type in a row. And when you had too many, I had to stop and get a generalizing approximation. And then what would that approximation look like? And then I listed a bunch of ways in which I attempted to approximate, and I failed one or more of my properties.
I see. Okay, well, the only I can just share with you one thing that in Scala there was a problem with infinite types. They were actually infinite, like the least upper bound was infinite.
Right.
Is tricks with f bounds and what in Scala 3 they did to solve it was union and intersection types. They just said this is the least upper bound, this is the greatest lower bound. So you always have something to go to.
Yeah.
There's some kind of trick where you had to notice it was happening and then just approximate.
Yes. And that's exactly what I have to do here. I have to notice it's happening and approximate.
Yeah.
Like I've been doing this for 25 years, but I haven't done it with types of structures. So I've done it with all kinds of other things. And Hotspot's been doing it forever today, but not with types of structures. So I just assumed the types of structures would flow the same kind of general way. And it turns out that's a much harder problem now. And I don't have an easy answer. Which leads me to my different attempts below. Sorry, go ahead.
Yeah, so it seems to me like your approximation function is kind of like underdefined. Like what you want is
Yes.
like usually when you're thinking about approximating, you're taking the limit of a sequence, and you're
Yes.
saying, you know, I've gone close enough to the limit of the sequence that I can stop. All right. And so like, I mean, so here, I mean, you're kind of, I mean, it's, well, like for one thing, you don't actually know what the limit is. So you're just kind of flailing around and you have to magically produce the limit point without knowing what it is.
Yeah, it's not magically flailing. I'm very specifically using neat because that gives me some kind of a limit that also has the property that it is a relationship with everyone else. So simple examples say, hey, here's a repeating sequence I want to find the limit of, but in an actual program, it gets arbitrarily complicated. So I can't go to, it's a sequence like this because I don't actually have those. I have some horrific graph, like I draw pretty pictures where I say, and here's a wad of graph that is arbitrarily complicated, right? Type graph.
Mm-hmm.
And now what algorithm works here?
I mean, the way I look at it is I try to approximate the function that you have that takes, you start with some type and then you go around the recursive loop and you end up with a more.
So you can stop right now and said, I went around a loop. Okay, the loop is whatever loop you have in your arbitrarily large program, including whatever happens across all call site inlining boundaries, because you could just inline them manually and you just have the same program anyhow. So as soon as I say I went around the loop, you have to define what, you know, and the body of the loop can be really arbitrarily complicated. And you can have irreducible loops and you can have all kind of nested loops, all kind of shit going on all at the same time. So it gets into effectively applying graph theory to define what it means, what it means to go around a loop here. And
Right,
I'm doing a lot of that work. That is going on.
Arjan's strongly connected component algorithm.
I'm doing strongly connected components. Yes, sir. Those are discovered all the time when I do these various meets and joins with these kind of things. I totally find strongly connected components.
Right, and so when you know something is a strongly connected component, you can solve it differently from that when it's just, you know, the meat of the random.
Yes, and that exactly is exactly what I'm doing. I'm trying to solve it, and I've listed a couple different ways I can solve it that also provide some amount of monotonicity guarantees.
Right, but what I'm getting at though is when when you have a component, you have two edges. You have the in edge and you have the out edge, and you're taking the meat of those edges. And so when you're just doing an approximation on one type, you have less information than when you have a whole cycle.
So, right. So there's this theory that says I should take all strongly connected components, which, by the way, you could, once you reduce the arbitrary loops to strong connected components, you have a DAG now of strong connected components, which you can then sort on. Okay. When you come to the component part, you want to say somehow everything in here is simultaneously meet across.
Right.
That's more or less what's going to go on in the what version here? The not attempted yet HM theory uses simple pointers. That's where I'm headed with that one. I could go back to, it's not quite the same. It's a little weaker than doing it per strongly connected components. But the problem I have been doing with strongly connected components is I have internal structure within them that I have to do some sort of property analysis on. And I am totally looping around and doing, you know, the generalized meet across things within the SEC. And I'm still having the issue that I don't get it's not like I only have one instance of alias 2 in that SEC. I have an arbitrary count of alias 2s inside the SEC, and they all have different values as they move forward. So within an SEC, I tell you I have a closed cycle. Okay, great, I have a closed cycle. What the fuck do I do with it between the elements inside the closed cycle? And the answer comes out to I have to do meets of one kind or another, or I fail ISA relationships really quickly. And that's where basically where I'm at. I'm stuck. I am already, all my algorithms already start by saying, do the directed acyclic graph until I hit a cycle. Now do the cycle thing. They're all doing the same thing.
So you can always coarsen to like the most genetic type. I don't know what it is in your type system.
Yeah, I call it the chop technique. The another attempt is to chop off the depth at some point.
So
yeah,
I mean the whole, yeah, you can just have it the most unknown, like I have no idea what this thing is.
Yeah.
Is it just you're unhappy with the quality of typing in this case, or why don't you? Yeah,
you very rapidly get a very poor answer. So
okay, so it's not that you can't find like a solution here, it's that the solutions which are easy, you're unhappy with the results.
That's correct.
Okay, got it.
So chop blows what I call property number 4, which is the one where the answers suck.
And yeah, that's a very vague defined property.
Yeah, it is. I agree. I would like to have cyclic types. People who are doing new allocations in a loop produce a cycle in the types. That's what I would like. What I mean by not suck. And so far, I've been unable to do that reliably.
Can I ask a question? Can I optionally annotate a type, like for I, in that for loop?
Yeah.
So one crazy answer would be, make me, if you get to your limit, just say, here's a compiler error, please annotate it, and then I can pick the one that I want it to be.
Right. And I'm trying to do inference.
And next time you don't have to spend time. It's just very...
So kind of Scala when you ask you to annotate a recursive function. So you just just write it. I will comply.
Right. And
next time you don't, the compiler doesn't need to spend time inferring it.
Yeah, it's not a time issue for the compiler. These algorithms run fast enough. It's just the
it's
quality.
The size of the memory it uses, or this.
No. The issue is the quality of the result.
The ugliness.
For the chop, it's the quality of the result. It's really bad. You quickly get a very bad answer.
Well, no, I mean, if you do chop and you go, oh, because it is infinite. I mean,
okay, so right. So one of the variations here, the meets downhill version, I can produce a program which produces an infinite answer.
Okay.
Infinite.
Yeah.
But that never terminates, and okay, I'm dead.
It's low.
Right. And in the property where I do the meet uphill, I can produce a test case for which it's not monotonic. And the larger algorithm around it that does, essentially partial evaluation of fixed point never hits a fixed point because you're not monotonic. It bounces between results because that's what happens if you're not monotonic.
I see. Okay. That would be,
And then in the chop version, I very quickly fall, everything interesting goes to bottom and you get shit for an answer. I use scalar for things that'll fit in a register, but there's a bottom type as well that includes shit like control and memory and stuff. But you very quickly run to whatever the localized bottom value is here. And that's because the chop is sort of arbitrary and doesn't have a clue when you more precision would help or not. And as soon as he chopped to force monotonicity, other folks who are not at that depth typically have to chop as well. And that's the problem that you now fall off.
is your chop finding the actual least upper bound?
No, chop is saying, I give up, I have too many instances of alias 2 in a row.
Yeah.
At this point, field F1 doesn't point to another version of alias 2, it points to bottom. I don't know, it points to some arbitrarily bad thing. Right, so that's
be quick to come up with an answer, any, and that's it.
Yeah. Well, my world is all, but not bottom.
The
Same
point-
kind
the
of thing.
point
Yeah,
here
whatever top or bottom you're going to.
So
when you have the loop and you meet the guy who's been chopped with the prior iteration of the loop, the chop kind of walks its way up into the approximation one layer each time around, and you only get stable when you chop the first thing off. And that's what I mean by you lose it. It's not quite the first thing I get, like one layer of struct in and then I chop and I don't know anymore.
Yeah, I always find that dissatisfying when you don't, it's not inferring the exact precise type, it seems unsatisfying.
Right. So I'm currently heading for the notion of I'm going to give up on the constant propagation producing me a cyclic type directly by itself. And instead, Hindley-Milner will bring the cycle back for me. So everywhere I would get a type that sort of grows and I want to chop it off, as soon as I visit a Hindley-Milner application site, which is every time I have a loop head, you make a recursive call, he lists the result that comes out of that right back to the cycle. So I can get the cycle back with Hindley-Milner, but I'm not getting it without Hindley-Milner at the moment.
I don't quite follow that. So what is you saying your type, like the data structure you have in while you're compiling along, is the type says cyclic somewhere? Is that what you're saying?
Yeah, so up in the T0 colon is and there's an AX0, and there's an F1 equals AX0 dollar.
Yep.
That's me saying I made a cycle.
Oh, I see. Okay.
I need some notion to write a cycle in the pure text, right?
Yep.
The actual data structures in memory that are the compiler IR, in fact, form a cycle.
Okay.
So when I pretty print it like this, but you get a dollar to indicate a loop.
I see.
You get a loop indication. That's not always a dollar. So I haven't got a proof that it never works either. So yet somebody may come along and tell me I'm being a doofus and just do this and it works. But I'm not there yet.
that would be generally a hard problem, at least to me.
Yeah, right. The distance from having the meet uphill version to coming up with a generalized counterexample was several weeks. The time I kept finding only in context of very large programs that were already complicated monotonicity errors. And it took me a long time to beat it down to a simple version that I could then beat down to, hey, here's what it is. It's when the F0, F1, and F0 fields have this property between them. So in general, the fail here is that T0.F0 is above T1.F0, and T0.F1.F0 is sideways to either the T1.F0 or T0.F0. It doesn't have to be directly a high, medium, and low like I'm showing here. It's a more generalized problem. It can be anything that's a little sideways, and you get the same problem. So the meet uphill is like really only valid if the nested version is equal or higher to the shallower version for all fields F0. You're gonna repeat on field F1, all fields F0 have to be equal or higher, not lower, for that to be a valid cycle, or else I can produce for you a T1 that is in between and blows monotonicity. Fine.
High, low, and medium integer values, or some type that's like
Some type that has some properties, like high, low, and medium would be integer ranges.
okay.
A high range might be the constant 3, and a
Uh-huh.
medium range is the range from 3 to 7, and a low value is a range from negative maxent to positive maxent.
Okay, I see. So those are subtypes basically, and
Yes, they have an obvious subtyping relationship.
then-
It doesn't have to be integers. It can be
So you're-
structures that have a subtyping relationship.
this is a struct. The @, sign means struct, I guess.
The
and then
@, struct.
One are fields in the struct.
Yeah, and that's
Does
fields in a
two
struct.
mean an array of two, size 2?
I'm sorry, two is an alias number. Call it a person object, a linked list,
Uh-huh.
a big integer. What object name would you like to give a name here?
Okay.
And so internally, of course, I just map the name to some number and it shows up in bit vectors and whatever. So
Oh, I see what you're doing. Yeah. So F1 is refers to T0 kind of, or something, or it actually doesn't.
F0,
Yes, it refers to that name. It refers to number 2.
two refers to some alias number. I can get rid of 2s because it's the same everywhere.
Oh, okay.
So it's a pointer to a struct, but I
Right.
want to make it clear that it's the same type struct every time.
Okay.
So the 2 refers to an allocation site within your program,
Okay.
such as down below where someone says new link, how to approximate I,
Mhm.
that particular program point for that link has alias 2.
Okay. I see. That's just, okay. That's like your internal alias when you're compiling along. Is that right?
Yeah. So
Okay.
I've turned the word link into an internal index 2 that is being used in the internal type description.
And so in T0, F1 refers to T0, sort of the same
T's,
structure.
yeah, same type, yes.
It's just a cyclic internally. And then what's AX0? Is it?
Approximate. I'm just saying, this is the approximate.
That is how you approximate it. I see.
That's the name I gave the approximation. You're looking at the approximation. I gave it a name.
Okay.
It turns out I need the name if you're cyclic because I have to write the cycle in a flat text format. I can't actually draw a cycle in ASCII text.
Okay. I see. Okay. All right. I'll study that. That's it. That's interesting.
Yeah, I would love to have more feedback on this. Like I said, I haven't convinced myself it can't be done. I have counterexamples on easy solutions. They're not, I mean, each one of these solutions takes me like a couple days to go implement, and then another day or 2 to sort out that it will never work. You know, here's a counterexample, I have a bug. Here's a counterexample, I have a bug. I just need to do this and they'll fix it. Then another counterexample shows up. And then after a while, I'm like, oh, I have all these counterexamples of the following property. And then I sort out, oh, it does not work here because of, yeah.
I believe most of the problem would come up with structures, unifying
Yeah,
structures.
it's all
or
structures because that's the
approximating.
only cyclic types I get. It turns out I actually have function returns can be cycles. That's an entirely different problem. That's also vastly trivial. It doesn't have multiple fields. So the structure return one, I think I have a perfect solution for that's exactly correct. But structures I can't do. Things that are not structured, they don't have internal structures per se like this, don't ever have this problem. So the ints having ranges, floats having ranges, not a problem, not a problem. Arrays have an element type within them, not a problem because they only have the one field. Functions having arguments aren't themselves fine. It's if, but I don't track function arguments on the float type system. I do function returns because Henley Miller does the function argument types already. Yeah, that's where I'm at. I think I'm going to do, you know, one of plans, you know, B or C down below. Probably C first because I've been doing that in other contexts and it's pretty simple to implement. So plan B here, plan C here. Oh, yeah, look at that, copyright notice. Thank you. Whereas plan B is what hotspot's been doing, and it changes the meet operator, which would be a big change. And the meet operator would then disallow having types with arbitrarily deep complexity that also ended up widened more than a fixed count of times. That might give me a better answer, and that would give me some leading prefix of nested types that would be okay, and then promptly cut it off at some deeper depth without failing the chops problem of being monotonic forcing or chop forcing failure to monetize unless you chop early. That fixes it. The widening fixes it. But it does get complicated because meat becomes complicated there. And the other version is that all structs are alike. All instances of alias 2, there's only one program point, but you can recursively make any number of link objects by calling the factory for link how many times you want from all paths in the universe. They all get run together. And I think that's the same kind of thing you normally get anyhow. So that's probably the answer I'll start with.
Say your F0 equals high syntax, that is basically the type of F0 would be inferred to be the singleton type of high, or
well,
type, or what is that?
Okay, so I'm trying to write types here. So
yeah.
Not program text, but
so
types.
the type that, yeah, high is the type of F0.
High is the type of F0, yes.
I don't believe it's all correct, but I try to come up with some Java-ish approximate examples. I don't know are they correct exactly.
Yeah. So don't put them in line here, like class list equals something, something. Move that down below and experiment, because you're going to be coming and going, coming and going. And my experience here is that I come up with a thing that seems plausible to me, and I make it work on my poster child example. Some other example comes along not too long later that breaks me, but I don't get it right away. So as I said in the last couple of weeks, I've greatly increased the amount of testing I do on Approx with basically fuzzing attacks and a bunch of regression tests now. Now I have a large pile of regression tests. So if you come up with an answer, I can probably hit it with a pile of tests and we figure out why it does and doesn't work.
I think it's interesting because like you mentioned, if you set I to 0, it's not an int, that's a 0, which is like a singleton type subtype of int. And then this structure sounds like you're doing a similar kind of thing where you're saying it's not the structure with alias 2, it's actually the structure with alias 2 with F0 set to high and F1 set to something else specifically. So it's more like a singleton type where you got, and you're keeping track of all those. So if you get several of them, you can find the least upper bound of that and be very specific and know how to optimize it later. Probably that's what you like to do.
I'm really looking for types to let people write more complicated programs and have them be type correct. So I'm treating this separate from, this is not the optimizer.
No, but
the optimizer does what the optimizer does.
It tracks it, but if your compiler tracks, the type system tracks more specific things, then the optimizer might have more to work with. Is that why you?
No, that's not why. I don't care in that way. The optimizer will always take as much as the type system gives it, plus it will find some more out. The type system is what the programmer gets to deal with.
Right. So your purpose of being that specific, like you could just say it's type alias 2 or whatever that is. Or
yeah, it can be done. Yeah, right.
That's
right. So suppose I want to know that the first 2 versions of pointers to the alias 2 are not null. And the user doesn't have to write null handling when he dereferences them. Right. So, you know, in the land of Kotlin and people who do null, not nullness propagation, there's a bunch of cool shit you do when you know that it's not null at the programmer level. The compiler has asserted for you that, and you don't have to deal with null. You can just start dereferencing. I have a T0 thingy. Thing type is a T0. Well, I can do a .f0 for free because I know it's not null. I can do a .f1.f0 for free because I know .f1 nested inside is not null.
Right. How do you model null in your type system?
Everyone has a specialized null flavor, and then there's a separate null object, which gets complicated. For in the case of aliases, I'll just write it with a 0 here.
Mhm.
that causes me to wrap on my line endings, which is suck, but, you know. Get rid of the star, put a 0, comma, still wraps. Let's see, get rid of another blank, something like that, right?
Yes. 0 means it can be nullable.
Yeah, yeah, that can be a null or not. Yeah.
Okay.
There's a little more refinements because the lattice is symmetric around a center line. So there's things that may be null, may not be null. I can choose it's the null flavor or it's not or whatever. There's a bunch of other flavors, but for most purposes, you would just consider, I have some easy way internally to represent this edge and the pointer graph can be null or not. It could also be a blending of various instances of alias2 and other things because I've merged several kinds of objects into some F1 field that I don't know which one to have. Like if I have subclassing of animal, I have cats and dogs and sheep and horses, then cats and dogs and sheep and horses all have different aliases, but they have some common parent alias that they come from. And I can represent all of that precisely in various ways. Any
Are
blending
all
of-
the nulls equal, or if I'm not a cat, is that unequal to being not a dog?
I can represent not a cat and not a dog. And separately, I can answer the null question in pretty much every context.
Right, but if I reach a piece of code and I say, is this pointer to a cat equal to this pointer to a dog? That's a type error, even if they're both null.
No, I'll say they're both null. If they're nullable and I don't know that it's null or not, then I'll claim that the answer is it's either null or no. But if it's both null, the answer is yes to the Boolean. Yeah, the Boolean question, is this pointer equal to this pointer? The answer is yes, they're both null. And I'll know enough to say after an if test, both of those fields are null, stupidly, because I'll do a join of cat and null and dog and null, and that will only have a common join ancestor of null. So I will be able to tell you that this is true if and only if both those fields are null. And that's built into the type system.
When you have two different null for cat and dog, and you do it, is why would it say yes if both are null? I mean, they're still two distinct types, right?
Okay, so hang on. So there's a different question I got. If I compare two pointers, so it's coming up to, let's find some code blob down below. Compare two pointers. One is typed as null or cat. So cat is a some predicate null or a new cat. Dog is some predicate or a null, a new dog.
Right.
And then I want to ask the question, Boolean B is equal to, cat equal to dog, right? Lowercase, these are things here. Okay, so that sort of what you're asking?
Kind of. And in both cases, so cat and dog would be both null. And you said you have distinct null types per type, right? So you would have a null cat and a null dog, basically.
It's not.
Isn't that
Not
what you
quite.
said?
All nulls are the same. You cannot tell nulls apart. This is a
Okay, so
theory,
okay,
not
fair
a-
enough. So I misunderstood. I thought that was what you're saying.
Okay. I'm doing a lattice, not a classic tree typing where you have a hierarchy of some kind. So all nulls can look alike, and I can tell apart null and cat from null and dog. So something, I don't know. Here, if cat is unequal to dog, then I'm sorry, if both are null, then the answer is true to the test. And if either one is not null, the answer must be false. And the type system knows this.
Right. Okay.
And now you're saying, is there a separate null for cat? Not really. Like I said, all nulls are the same, but they're not in a tree structure. They're in a lattice. So you don't get a tree hierarchy where null is a subtype. Cats are subtypes of null, and null is subtype of cat. That's not what happens. And in particular, integer null and pointer null are also indistinguishable in the type system. So stupid things like this are allowed. It just sets some variable cat to a null, sets some count to a null. Count might only be doing integer things. Cat's only doing cat-like things. I had a cat named Pete who died last year. So there you go. And get rid of my capitalization here as well. So that's legit in the type system. Because all zeros look alike. All nils look alike, or whatever you want to call it. That's sort of a separate question from, like, the meat problem I'm going through with approximation has to do with how to approximate in a lattice. Nil is in my lattice. So it's part of the same problem, but as long as it follows the rules that meat follows, I don't really care. So now I could, in your example there, give you a type error and claim, give you a compile time error and complain that this is basically a complicated, subtle way of writing false, or a complicated, subtle way of demanding that cat and dog be both null. And that's probably not what you intended. So I could flag it as a type error, but the type system itself, like, knows what the hell's going on. In fact, this is probably better done as a type error. You're comparing two unrelated types. This is only true if both are null. Is that what you really wanted to do? Or no, don't do that. Test for null instead and be obvious about what you're doing.
You
Do you
mean
plan to-
you're not trying to do JavaScript too?
Oh God, you know, I did JavaScript. I wrote a bunch of front-end application things, and the count of ways you can say null or not null or is true or false is just like blows me mind. Just like, no.
Don't forget about undefined.
And separately, there's undefined. No, I don't have an undefined notion that won't pass muster. And you know, I have a nillable. I have a truthiness. If you're null, you're false. If you're not null, you're true. And that covers everybody, because null can be everything can be a null or not a null. And that's the only thing. Like, empty string is still a string. That's not null. So that's not truthy, or that's true, not false, or falsy, or whatever the fuck it is. So integer 0 will be false. And integer 1 will be true. And actually, I don't have a separate Boolean type. I'm just doing integer range from 0 to 1 for my Boolean type. Fine. Do you want to move on from here, or people have more questions here? This is like thick and chewy theory shit. Yes. Uh-oh. Here we go. Somebody put a comment in here. Excellent. Yeah, I'm going to not be in this camp. Yeah, in all of these cases on the perimeter, I would say those are not equal to 0 or false. Empty arrays is still an array. Empty string and the 0 string is definitely not getting freely converted to the 0 integer. You have to ask to convert an integer.
The one that's tripped me up is strings that contain only white spaces.
Oh, that's the /t one. I was staring at that.
A string with a tab is white space, so that's the equivalent of the empty string, which means it equals 0.
Right. Oh my God, the Holy Trinity, there it is.
A tab like the Holy Spirit is invisible.
Yes, 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 yes. All right, all right. Stop hurting me before this goes any further. Man, somebody had a question here.
Well,
Cat is
what-
typed as a cat, a pointer to a cat object is null. Type of cat would be, well, okay, so sort of stupidly trivial, it's cat has been assigned a final assignment with a plain assignment operator of 0. So it in fact would be null. If instead it had a colon here, this would be a variable assignment, a var, a mutable value, now to be type of cat or null.
Ah. Oh, sorry, I was not muted.
Do you want to leave both versions in the doc?
Cat or null?
Yeah, we can do that.
How do you write cat or null? The type.
Well, as a type, well, I don't put a pointer here. I'll just say cat is a cat, and that implies a pointer to a cat. Let me figure this out here a second.
Oh, I see. Yeah, that makes sense.
Okay.
I saw that. I saw you did that before. Thought that was.
Yeah,
clever.
and I don't have. It's a question mark. It's this.
It's question. Okay.
Yeah.
Yep. That's what a lot of languages do.
Yeah.
So I was just going to ask, so, like stepping back, brand new language, why have null?
Because it's I've used it all my life and I find it very convenient. It gives everybody a version of no such thing here. And all hardware on the planet supports a more efficient version of doing something with null.
Okay.
So somewhere between those two, I find it convenient.
The thing I think is that the $1 billion mistake wasn't null, but that it wasn't tracked in the type system. So do you always track it?
Yeah, yeah.
Okay.
So every possible thing has null or not. Like I track
yeah.
those zeros and integers. So you asked, do I track it everywhere? Yes. So
yeah, like it's either, if it's a cat, it can't be null. If it's a cat question mark, it could be null. That's like an option.
yes, but there's same thing for integers happen as well.
There's what for integers?
The same thing happens for integers. So I have a count, I typed it as an integer.
Yep.
I set it to 0. His type is actually, I'll declare his type as, int64 here.
Yeah.
But I can also have a count that is, I don't have a way for you. Well, I can have a way that you do it here, nint, which is non-zero. And you could argue I should do the question mark instead.
Oh,
This
no.
is actually, I need to be mutable here. Hang on, I gotta be mutable. If I'm not mutable, then it's actually 0 directly. It's the nil
Correct.
again.
Let's see.
Okay, so type is nint.
Those
Integers put 0.
would cause you a big headache when it's no, when it's not no, when is it a question mark or is it something else? That would cause trouble.
Well, so that's a syntax question. Yeah,
And int is different than uint.
Well, to me, that's not null. To me, I like nint, but you stop with nint because or not int, non-zero int is really,
Non-zero int. Yeah, I don't. This is internal. Like I don't have I don't expect you to write this, so I
Oh.
haven't thought about what's a good syntax to write it for.
I see.
But I know something about your integers. I know the same thing about your floats and your arrays and every other thing on the planet.
Yeah, but you can't tell from if they just said CNT : =1 that's never going to be non-zero. So they would have had
If you assign a type to it,
yeah,
like nint,
yeah,
then I will verify that in fact you never assign a 0 to it,
yep,
or you'll get a compile time error. I can't prove you didn't put a 0 here.
right. Yep.
So all assignments, future assignments to count have to confirm non-zero.
Yep. Okay.
And in particular, if you increment count like ++, I know that it wraps. And therefore, count ++ and an undetermined infinite length loop will in fact hit 0 eventually. And so that's not legit. That'll be a type error. Mostly I see these internally as just part of doing the math on whatever I'm doing math on. Somebody's writing I'm writing Fibonacci and shit like that. Oh, I know Fibonacci is never 0. but it might, get big.
Mhm. Okay, so the int I mean, well, let's go back to cat question mark is like a union type in Scala 3, cat or null. And that's like one special union type you have in there. It's either a cat or it's a null. I mean, if you think of null as a type.
Yeah, I don't otherwise use union types or think of it as a union type.
Yep.
I
That's correct.
understand that people do. I don't have general union types here because I don't like what they do to the runtime of a bunch of algorithms. Well, you already ran this issue where somebody has to stop and approximate you.
So what about at the library edge, like when you're calling into existing libraries from AA,
Yeah.
where things aren't, null isn't tracked? How do you,
Right.
that's like always been the pain point for
What?
the
Right. Okay. So calling into it is free. I just hand the guy a not null value. It's getting return out of it. I get an answer back.
Yep.
I'm just going to assume it can be null unless there's some other assertion made by somebody that it won't. Now I saw this language called Elm do a thing where he said, I will check the types of all returns to foreign function interfaces.
Yes.
Before I let them in the system. So if you have a type error because of a miscommunication across an FFI boundary, it'll get caught at the FFI boundary. And I kind of liked it. It does add overhead to calling an FFI in exchange for catching that class of errors at the FFI call instead of crashing and burning later because your type system internally got broken. Right, as soon as you say, I know something, and then the optimizer goes to town on knowing something, he takes all the shortcuts in the universe. If you lied, all bets are off now.
How do you handle a cast?
That requires a runtime check, like an upcast or downcast that you just.
So the example I was thinking of is I'm reading bytes off the network interface.
Yes.
And I go, okay, this is a IP packet, but I don't know if it's v4 or v6. So I need to cast it to some kind of generic IP, check the first few bits, determine if it's v4 or v6, and then cast it to either a v4 or a v6.
So I would claim that you would take 4 bytes or however many bytes in your packet in to a generic IP constructor whose subclass is 4 and 6. And then somebody internally decides I'm a 4 or I'm a 6 and produces a factory that gives you a value. Same thing you would do in like Java. They have a horrific thing where they say somewhere in the universe we decide this is valid for a 4 or it's valid for a 6. And I separately call new IP4 or new IP6.
Right, but I need to be able to check the version bits.
So
the only field I'm going to be able to look at is the fields that exist both in 4 and in 6, because at that moment
so
I'm looking at a byte buffer that's in either 4 or a 6.
That's a general upcast or whatever. It's like I have a class hierarchy for animals with cats and dogs and horses. There's an animal that has a leg count as a virtual field, but there's cats who have like meow volume, and dogs have bark rate, right? Which is something different for everybody, or wag tail rate. So you have to do a cast. You have to runtime cast. So there's some syntax I'm experimenting with. This is all.
But I only need the cast if I'm accessing a field that wouldn't be there.
Yeah.
For all of them.
Right. So I have a thing. So some animal, I don't know what it is. I'm going to put a question mark cast on it, which is I'm going to cast it as a cat. So the animal is my local name. Cat's a type. Question mark. Now animal is a cat-like, and I can say something about the meowing. Otherwise, it's not, and I can see something about that's virtual about the legs, right? So here's an option for cast syntax that I don't necessarily like.
Yeah, that's a little too bit shifty for me personally.
Okay, yeah, I don't know.
But is that any different than just as a function?
No. Other than it has.
I guess for it to just be a function, cat has to be a realized type that has a pointer to somewhere.
Yes. Right.
And you don't want that. You want this to be a compile time idea.
Well, yeah, right. I mean, there's implementation and there's semantics. As long as I can give you the performance guarantee that you get a fast, efficient runtime check for animal is a cat type thing, then I claim that you don't care because you can't tell the difference. So if I wanted to have a function, then I have a syntax difference where cat here is a reified, reified type. Is that the function syntax I want to write? I don't know. Do I want to allow this optionally as a syntax? Okay. Hey, look, this looks just like a freaking operator. Here's my operator syntax for the same damn thing. And I
Oh,
could
yeah, that makes sense.
Go back and forth on it as an operator.
And if I want to call it as a function for whatever reason, I just underscore is a underscore
just
call it like a function.
Yeah, yeah.
That's not too bad.
Actually, I probably would put that as an instance field on cat and say it's this. Have this right. So I need to sort on it a little bit. I guess animal could have its instance field. And then it would be and that has to be a pretty generic operator call cat. So I could go there. Right now, cat is defined as a type, and if you use it so there's a type assignment here. Maybe whatever. If you use it in a type context, you use the word cat, you get a type for that. If you use it in a execution context, then you get the constructor for cat, which is already enough information for have me sort out an animal take a constructor for cat, and he does the test and can give you an answer. So I could do that without really any semantic changes to how things work as it stands right now. Other than becoming a very popular, low-level implementation, very common implementation field. I already have like EQ equals as everyone does equals. So everyone can do an ISA as well.
And now if I'm doing my IP stack thing, my IP just implements an ISA.
Yeah. Well, it would inherit an ISA that would do the job. Whether or not I make ISA overwritable is a different question. I'll probably give you a fixed version. You can't change it, but it would support having subtyping notions. The usual way I'm doing ISA right now is it's structural unless you want it to be nominative. And so I just do a field check and declare, yeah, your IP4 thingy has all the things that make it an IP whatever. Or this thing has all the fields made IP4. Something like that. So there's a way to do a cast. I'm obviously arguing out syntax. Here's somebody in the chat. Meow. Voice meow. I'm not sure what you're trying to imply there with the chat, Kirk. There's for instance, cats might take as a constructor the 1, 2, 3 for their meow volume or whatever the hell, or the kind of the voice or something. Yeah, so for me, moving from a collection of primitives to an object is calling a constructor for which you get a default constructor for everybody that takes all the fields. But you can have other constructors if you want. But the default constructor would take 1, 2, 3 and the number of legs 4. And I'll do, here cat is equal to a lowercase cat is called cat with 1, 2, 3, 4. This gives you, sort of what you want. If I want to have a default version for legs, I can make a version that doesn't take legs, and I don't have to put legs in. Or inherit from 4-legged animals instead of from millipedes. So there's definitely a way to go from primitives to things.
If we have that kind of ISA relationship, it wouldn't be that hard to write a pattern matching to make that prettier, the whole expression here.
To make the whole expression what?
More expression prettier with a pattern match. We can use ISA as a base for the test for the case.
Well, okay, so now what's pattern match? Is you're talking about what pattern match syntax would look like?
We can implement it in terms of a ISA relationship here.
Yeah, right.
Specific.
Yeah. So this is some case statement here. Result is equal to case. So come back here. Case of animal, and then I can say cat arrow dot, and then here I can say animal dot meow, and that's okay. And here I can say dog. Is this what you're talking about?
Yeah, it will translate it like an ISA, and it will be prettier, of course.
Yeah, and I can put a nil in here.
I mean, the value of case is less that it's pretty and more that it's complete.
I would vote it here. Yeah, that would make it complete.
And I could demand completion. And I could
complete,
demand.
we're talking total.
If I have a match over 64-bit integers and I cover everything but 0, I want it to be like, dude, you didn't actually cover your type.
Yeah. Well, that should come out if I'm covering things. So I haven't thought about the pattern match, but that's the obvious thing. Okay, I already have the meet operator defines ISA. The type system understands ISA directly. So anything that requires an ISA-like concept, like pattern matching, you just use the internal types. It all comes out in the wash. And then it's the question of syntax. I could throw in, desugaring pairs and all kinds of other things, or I could have things that weren't cats but had cat-like fields. So anybody who has legs, right? And this would be a case where anything that has a field called legs, I can use it as a legs here. And there's a string converting to an int. I don't know if that's the right way I want to do that. I might, do something like here. %d is an integer representation for the embedded string type for the variable legs. So that defines a structure that has legs on the left and it pretty prints a string on the right.
Yeah, but that would be interesting in this case because legs is automatically bound. It's a structure that has to have legs and automatically bound.
It's automatically bound. Yeah. So I can do pattern matching like that. I mean, I don't have that in there, but this is totally doable in the syntax and the grammar. A parser needs some little love and make it happen. The type system will support it completely. It's all fine.
How this check has to be resolved at runtime because you don't know how this would translate at runtime.
Yeah. Yes. So this requires me to do an ISA test at runtime.
Yeah.
So an animal comes in as some arbitrary animal thing. If it's an instance of a cat or a dog, I'm going to do one thing or another. Those are all 1 clock cycle tests. Then I have a legs check, which actually is going to be a 1 cycle check, 1 clock cycle check. There's a nil check, and I'll have to do them semantically in order in case the legs one overrides or cat overrides legs. So each of those tests turn into a runtime check that's roughly a clock a pop.
That would be interesting.
Yeah, there you go.
To be honest, I don't know if that is interesting. It kind of goes down the road of implicitly implemented interfaces like Go, which I think is a pretty stupid idea.
Okay.
I believe it goes into the structural matching realm.
Yeah, this is row polymorphism. Yeah. I believe, Matt, that I have row polymorphism. This is one of my goals was to have row polymorphism.
You
So
should
I
always need the
But idea, Chris.
runtime check for this, but it may depend on the type system. I have seen it done without runtime checks.
Well, I have to, in the case of the case here with the animal, if I don't know its type more specifically, I'll have to have some sort of runtime check. I might know animal always has legs. I can know that.
You
might know
wouldn't
it's-
know that lex is always integer, right?
And well, yeah, this is because I'm going to, well, the %d says cast it to an integer in the pretty printing answer. But separately, I might know legs is always integers as well. Depends on how people assign to legs. No one has given me a constraint on legs that it must be an integer.
That would be arguably harder. Yeah.
But no, but I'll prove what legs has sort of straight up, and I can validate that %d is correct here. There isn't a type assertion given. It's %d demands legs be convertible to an integer.
Yeah, but if you have more implementations, one for int with legs, one for string with legs.
Yeah,
How would
then
it
you
go?
get a type error.
Hmm.
He'll blow up and say %d, but legs might be a string.
Okay.
So I could have compiled a whole world where legs is always an integer.
Yeah.
And then suddenly someone adds a new thing to my universe that has a float number of legs on it.
Right.
Do I now need to go find all of the call sites that took an animal and recompile them because the universe now contains an animal with a float leg?
Okay, so at compile time boundaries, you're going to have some notion of what those types are. The system will know what those types are. Somebody changes the animal, it gets a new compile time boundary where the legs field is now int or float, or maybe it's floats that subsume small ints or whatever.
I called eval, I added a new type to my universe that is a subclass of animal.
Okay, yeah. As soon as yes, if you call eval and you add new types to the universe, you can get a compile time error at the point of the eval saying, hey, you wanted to add something, but it don't match the current types. And here's your type error. Eval gives you two things back. It gives you a syntax error, or it gives you the result of the evaluated expression. So you.
So I think of your compile as a work list where you keep adding neighbors when something changes.
I'm sorry.
Your compile is basically a work list. You keep adding neighbors when something changes. My question is, can I?
That's certainly not how I'm viewing it.
Add a new small snippet of code.
Right.
That suddenly means, oh, this invalidates a bunch of assumptions of its neighbors. And then those things get recompiled, which invalidate assumptions of their neighbors. Like,
okay.
How do you know that an eval doesn't cause an arbitrarily large amount of recompile, potentially including the entire application?
Let's restart that. Right, exactly. So let's restart that. So you only the REPL at the moment basically continuously adds code. But the bulk of the code that you would type in a REPL, all of it taken together will be all typed when you add a new instance. If that failed to type, it didn't get added. But that's the REPL. If I'm not in the REPL and I'm running a program and I never call eval, this problem doesn't show up. If I call eval, at the time that I call eval, I'm going to take the context that's around the eval and just the code that's in the eval and type it at that time, or fail to type it. And if I fail to type it, you'll get a syntax error back, but I don't touch the rest of the program. Now, if you've typed it, you get back basically a thunk, which you can now execute. If you execute it and it changes the world around you, it does in whatever way it does, including perhaps you're contemplating it changes types. Those types will still be restricted to be within the scope of the eval. It can't do an arbitrarily far removal thing. So if you already have legs as an integer and there is a constraint which demands it be integers, because if there isn't that constraint, then the type system knows it and legs can be whatever. But if there's a constraint, it has to be an integer, and you say, hey, here I set legs to 3.14, you'll get a syntax error in your code alone, in your eval code alone, that says legs is not a float.
I guess then my flip side question is, if there's only enough constraints in the universe to say, hey, legs needs to be either a float or an integer, but it just so happens that all of the examples in the entire universe, it's a uint8.
Yeah.
And there's nothing with more than 256 legs.
Right.
I guess the runtime can say, I'm going to use this much tighter type and just be prepared in the event that something happens and it needs to deopt.
Okay, so I don't have the type for general ints and floats, but I do have the type for uint8, which is subtyping general floats and general ints both, because it's a lattice, it's not a subtyping, it's not a tree. Fine. If the runtime says I've chosen a representation of a uint8, and you came along and said, hey, the general value would be any integer or any larger, int 64 or int 32 or whatever, then it's the runtime's problem. He chose a tighter value or tighter storage medium. He has to refigure how to do that.
But the problem would be that legs now have to be interpreted as either as float, either in.
Okay. So the type system as it stands right now doesn't understand the difference between a general int64 and a float. So you can't have both of them. You can either constrain it to be an int32 or not.
Mm-hmm.
If it's constrained to be an int32, it can widen out to an int64 or widen out to a float 64.
Yeah, but for the purposes of representation, it can discover that it can fit on a small integer constant, the float.
Now you're getting into the optimization strategy of things.
Mm-hmm.
Somebody took an S off of legs. There you go.
Mm-hmm.
So, and the optimizer does what the optimizer does and has to preserve all the semantics of the type system. So if the optimizer chooses to use a tighter representation for legs, it did so, but it better have a fallback plan if in fact some bigger answer comes along. Hotspot does this all the time. You have this field, it might be null or something exciting. I've only ever seen a null in this field. I'll only compile the code assuming it's a null. As soon as you put a not null in there, oh, I got to go back and recompile.
It will speculate, yeah. So
it's a speculative optimization, totally.
Yeah. Okay, but what would be the compile time type of legs? Because you have seen a float, you can see an integer. Should it be just easily let it be integer or a float? That would open the door for a lot of, should we say, holes.
So if you haven't seen any floats, or you've only seen if you've only seen small integers, its type will be small integer. I'm sorry, the most general type would be, it would be small integer.
Yeah.
No, hang on. I've gone back and forth on this one because I want to not have to deal with like a small integer will cast into a float for free. But if you're just putting integers in it, I'll declare you an integer and assume that you will go up to an int64. And therefore your typing will, unless you've said otherwise, and you're doing integer things, you'll be an int64, not a float. If I also observe you're only doing small integer things, I might say you're a small integer. Am I going to bind it? You're proposing that I have to bind it at that time. Like, what is the maximal type?
Mm-hmm.
And the maximal type would be.
If you type the legs should be 3.1, it should stay a float, and with the caveat that it should be small integer constants all over the place. It can subsume a float. So it can
float can subsume small integers.
Mm-hmm. Yeah.
But not the other way around.
Yep, because you can you as soon as you type a 3.1 legs, it has to be a float. It cannot be integer.
Yeah, I won't. I'm right now. I believe I'm not letting you go to the float side unless it's in my face somehow. If you're closing it off at a closed universe, you'll get an int64.
So the the problem, the minute you type 3.1, the type system have to check, so can it be made consistent that all over the place are small integer constants, then fine, it will let you type it as a float.
So this comes, right. So this comes down to the type system knows it's small, at the moment, it knows it's small integer constants. I wanted to make a module out of it. I'm going to close off the type. This is my world of types. That small integer constant will become an int64 probably. And say, I'll take N64s everywhere, but not 3.14. And it'd be a type error to use 3.14.
So at this point, it has to be the type error. You are using legs as a float, but it is an integer.
Right. So there is a notion of a module boundary or a closed type system boundary where the types are all completely known. Right. And at that point, I'm going to say, I've only seen integer things. I'm going to assume that any wider integer might appear. There's another version of this, which I don't necessarily like, but would totally fit the typing model, which is to say, I'll take the tightest integer I have at that point, and that declare you that's the type you have, and you're stuck with an int 8, and you cannot hand me 300 legs like a millipede, because I'll say that's not an int 8, and so you lose. I think that one gets too aggressively tight too quick. And so I wasn't going to go there. I was just going to say, if you don't say something, go to int64 from small int. But I've also said to myself that at module boundaries, I want you to fucking tell me what the types are, because it's a good documentation.
Yeah.
I'll infer that your types match what you say they are, but at a module boundary, I don't need them because I'll infer, but I don't want to infer. Fucking tell me what your types are at the module boundary. At that point, you can say it's int64 or it's float64, and I'll be good. I'll say, well, int 8 is less than float64. You're happy land.
Yeah.
Have you considered taking a middle ground and saying, if I have an integer and I know nothing about the range of the integer, because it's like counting to infinity, but everything I see is small, calling it a signed int 54, because now you're in the union of the int 64 and the float.
I have totally thought about that. That one gets this funny issue of, if you later come along and you do UUID things with it, you wrap it 54 bits. So it could be done. And I don't know if it makes a better system or not. Maybe it does. One says I can grow from small ints to float 64. One says I can grow from small int to int 64. Which one's more common? I have to make one of them lose at the default place where I'm picking what you're going to lose, which right now is the module boundary, and I didn't do a default there. You told me what it was at a module boundary.
So that would be the critical piece. The module boundary defines.
Module boundary comes along and tells me how I should widen this guy or what its limits should be. Or whatever.
So it's kind of a quorum what the type should be, and from this point on, from this side on, it should be only viewed as an integer.
Yeah, well, if I determine that internally it's only int 8, and externally you said int, I'll say that's compatible. I know it's int 8. If somebody tries to get a value from me, they'll only give me int 8. If it's an input argument and you said int, that's another use of a full 64-bit int at the module boundary.
At the counter side, doesn't this make the program much more fragile, because it would be susceptible to interpretation?
If you've declared an input argument as an int64 down from a scalar by default, I'll take it as an int64. If you don't give a type to that input argument, that's a module input boundary. It's like type is a scalar. It's fucking, I don't know what it is. It's anything on the planet.
This approach should be workable, but we put much more stress over module semantics. That has to be.
Okay, the module semantics would be strongly typed boundary. Every function is visible, and every argument and every function is all understood as what their types are. And then I'll do an is a check for all the callers into the module. And inside the module, I know that I can have these callers for all the values. And that's what I'm doing right now.
Yeah, the module should they should be checked for consistency at the module boundary, which would be much more quickly, because if you have to check the consistency for all the methods, it will become pretty much messy. But at the module boundary, it should become a workable approach.
One's a speed issue, which I claim is not the problem, and one is consistency, which
Yeah,
you have to check.
consistency. Yeah, agree.
And here for this one, it's an is a test, which is pretty quick.
Okay. Cool. Okay.
So we talked a little bit when you were first trying to decide what to put in your type system about pony.
Yeah.
And the distinction of this is a unique pointer, or only local aliases exist, or global aliases exist.
Yeah.
This seems to no longer be a part of your type system that you're thinking about.
No, I'm still thinking about it. It's not, there's no implementation details, but I can carry along extra bits like mutable fields or immutable fields. I can carry along single instance, shared thread local, globally shared as an extra bit in the type system. So if that's not been implemented, it could be done.
And that's data that exists at just compile time or at runtime also?
So as soon as it consists at compile time, it's freely available at runtime as a constant value. So as soon as I know something about the type of this field, the runtime will assume that he has it as a constant. Like somebody says, I want to ask the runtime question, what is the type of cat? Which is, Bill was asking. Okay, the compiler knows, the type system knows. So his type of cat at runtime is a constant. It'll be, pointer to a cat structure with the nil or not the nil as the appropriate and the fields and blah, blah, blah. That's a runtime constant.
What if my cat is some kind of tagged union and I call type of on it? Is it going to say, hey, this is a tagged union of one of these 4 things? Or is it going to say, this is thing 5?
No, this will be, the compile time type would be, this is a tagged union of one of these 5 things. There's a separate test which says upcast me to via a switch syntax to do the runtime test. Look at the small enum and pick the 5 fields and which one it is. So you can add an is a test there, which checks that tag union, matches the is a property. All these things are runtime tests, but the type of the thing you just described would be tag union. It's basically a subclass.
I assume you're planning to keep around some kind of type table that has the description of the various types.
Yeah, that gets into
like the thing that type gets replaced with, I assume, is a pointer into the type table or an offset into the type table.
This is a runtime question. There are lots of ways to skin that cat.
Yeah, implementation question, definitely.
Okay. The current thesis is I'm going to have some field bits set aside for what amounts to a vtable-like thing. Now, how many bits are set aside and how fancy the vtable gets depends on what you want to do in the optimizer and the runtime implementation. If the typing system knows at this point, I only ever see animals, there are only ever 4 subclasses of animals, I need 2 bits to pick out which animal you are, then maybe the runtime tag bits are 2 bits. If you're in the Java world, the runtime tag is a full pointer to the vtable. It's a 1 word, whether it's 32 or 64, it's a full word. You go to the Azul implementation of Java, there's a class ID number, it's like 19 bits. Covers all the classes you're allowed to have, which is several millions or hundreds of millions of classes in a large Java object. But only 19 bits means in a standard 64-bit header word, have a bunch of other bits for the hash table and the locking bits and blah, 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 blah. This is all runtime questions. So how many bits? Some, not 0. And it could be 0 if I knew exactly you're a cat in all contexts, and I don't care that the animal has dogs and horses and ponies. I don't care, right? Maybe. You could arrange for a thing where he just inlines the way the vtable like the class ID like thing. Now, how to do a vcall on a virtual call, that's going to be something of the akin of take those tag bits and do a table lookup, which will get me the base of the vtable, which will then do a field lookup. And maybe you can skip one of those lookups and just say, I'll have a hard table for each of the different fields. And I do the class ID into this table for the leg count and this table for the the pet name count or whatever it's going to be. So these are all implementation questions. How many loads you go through to make a V call if you don't actually know what the target is. For Java, it's load, jump register with some fair amount of screwing around. It can be dropped down to 2 loads in a jump register. Getting down to 1 load in a jump register is probably pretty hard. Starting from scratch, and I don't have to support a bunch of things Java has to support, I might be able to get it down to 1 load in the jump register fairly easily. But that's all runtime questions.
And those bits would both be used at runtime to figure out how to do virtual dispatch. And if I had some kind of core dump to figure out what all my types are, but I'm trying to actually explore my core dump.
If you're doing a core dump thing, you'll need the types that came with the unit to understand that core dump, but you would anyhow. You know, if you're looking at Java core dump, you need the types anyhow. You got a bunch of a pointer off to something else. Was it a pointer to an animal object, or a pointer to a big integer, or a pointer to a IPv4? No, you need that type table layout, the mapping. So yeah, using a mapping and those bits, you could just decipher a core dump.
Yeah, I do like the idea of keeping information around that may never actually get loaded into memory in normal runtime, but that when something goes wonky on me, I can dump it, load it on a debug machine, and start poking at it with eval, because the reflection data is at least there in the dump.
Right. It's available somehow. Now, whether or not it showed up in your binary you launched it from or not, you could imagine stripping a binary down, getting rid of all that, have a much smaller binary, but you can't now debug it. Standard thing we did in Hotspot all the time, of course, is you took the build, which was stripped to the nth degree, and you had a separate build that you had all the debug info, and you merged the two. Now you can walk your core dump. And the way the C compilers are doing it forever and a day. You want to debug.
So is your instinct that the default is all those debug symbols end up in the build, unless I say, no, for serious, give me the small one, in which it says, okay, here's your runtime thing, and here's your extra junk for debugging it if you ever need it.
Right. Like the standards for cell phones and desktop and servers is such that that debug info is cheap in terms of storage. If I'm trying to debug a tiny little Bluetooth thing like I did a couple of years ago for that startup, where the actual total memory space on the device was under a megabyte, I have a different criteria for, and so I think the default would be, you get all the debug info. It's free, have it. Hey, my binary is now 10 megs instead of 1 meg. I'm pissed. 10 megs, it hardly makes a dent. I mean, I can't, my terabyte drive cares not about your extra 9 megs.
Yeah, if I could tell the ELF file, don't even load this stuff into memory, I'm probably not going to care.
That's about runtime performance.
Disk is cheap.
Yeah, disk is cheap. Runtime performance cares about startup a little bit, and you just have to flag it right such that you're only going to load what you need to load to get going. Like jar files don't load the entire jar file. They load lazily as they're touched.
Yeah, I definitely need to spend more time reading like how ELF works and knows what things to load and not load.
Oh yeah. I used to know that at some point. It's been a while now. Matt says, early question, eval and validating the world. Yeah, as soon as you allow eval to escape some narrow context, you have to recompile everybody, and world age is an interesting one. My current thesis is eval is boxed in the current scope. And you have to export any side effects it has outside that scope explicitly. You get a thunk, which evaluates and only gets to touch things that are mutable within its scope visibility. If you publish things to an eval, the type system knows you published to eval. Eval, as a consumer of an arbitrary large scope, is assumed to mutate all mutables to the worst possible answer. So as soon as you say, I'm going to let my eval touch my universe, you've effectively made a REPL, and the type system will treat it like a REPL. Everything will be, sucked for types at whatever, because the eval comes along and crushes them. And in fact, you could implement a REPL that way. That would be just exactly a read eval print loop. Da, da, da. Ooh, somebody did.
And if I wanted to, I could make the subscopes more powerful by just passing in my eval. If I need to call a
I'm sorry.
library and I want that library to muck with my world, I can be like, hey, library, here is my eval.
Yes.
You can now muck with my world.
Yeah, and you have to agree that the library get to do whatever the hell it wants to you then.
Oh yeah, if you're
Yeah.
going to pass your eval to a library, you better trust that library. It's your trusted computing base now. Deal.
Yeah, yes, that's correct. And that will show up in the module boundary as you are going to pass me in your scope. I don't have a way to define that directly.
Oh,
I
if
do.
I pass my eval
Yeah,
into
yeah.
your module,
Yeah, the
you
module
can now
doesn't
mess
care
with
what
my
it got.
module.
Right, the module got an eval, got a function call that he can call. It happens to be your eval. Where you pass your eval along, at that point, I know that that eval came and crushed all things in your scope. So after that library call, I just assume you know shit about your scope other than final fields and whatever can't be touched by the eval. Everything else, the eval came through and crushed you. And it also, by the way, read all your secret keys and everything else, which I don't know what to do with that. That's a security issue I'm not thinking about. If you agree to hand off your security code to, you know, hacker.ru website, so be it.
I mean, I certainly like the passing your eval around better than a pseudo concept.
I don't know what pseudo concept is.
I don't want to be able to say, I would like to run, but I would like to run as that module over there.
Oh no, I don't want to do that. Oh God, okay.
But because I know the password, I can do so. And it's like, no. If you want to run as that module, call that module and say, please give me your eval. And it either will or it won't.
Yes, exactly. Yes. Yep, that's the current strategy I'm running with. And when you say pass me my eval, it really means I pass you an instance to your pointer to your local frame, your scope frame object, which immediately means all fields within it can be, you know, wackadoodled. Yep. That's basically in there right now.
Yes, it both feels like something I want to be possible in the language, and I want to tell every developer never do this.
Yeah, and you know, somebody will get smart and do it, and they'll have a good use case, and it'll look pretty, and then they'll get bit later. But you know, fine. I mean, JavaScript does it all the time, and I enjoyed some of the JavaScripty things that did it, but I knew full well that I was trusting, you know, React and MobX, and what was the other one I grabbed? FlowScript. There was another one. There's some common set that people run all together, does some cool shit by tracking side effects that you do to all your variables and mapping them to DOM effects to update the screen in an efficient way. But it means that every read and every write of every variable is hooked, which means that every variable can be written to by the MobX guy, and he's going to backcall into the React guy, and you know, and you better love MobX because it's going to love on you. There you go. Elf, put them all in the chat, and not chat, in the doc there. I don't know if those links made to the doc map. There's a link section up above. Oh, there you go. World Age and Julie. Yeah, I knew about World Ages in that way, and I knew Julie was doing that too. Actually, I read that before. And Elf, okay, fine. That's if I get down to Elf things, I'm gonna go deal Elf things. Somebody wants the static copy of the logo. Just take the animated GIF and ask for Giphy to give you the last page of it. That's what I did. I can go get another copy of it. So if you wanna swag in terms of T-shirt, send me a mail saying I'll pay $20. If you want a patch, if I get enough love for the patch, I'll go make a run. We're actually thinking we're going to do it anyhow. We're waiting for the patch people to go on sale. I say patch, it's sticker. They're really cheap. And then I'll need addresses from people. And stickers are free other than postage, basically. So I'll just send a sticker. But if I get them, I'll ask for your address. Send me your address. You'll get a sticker. If your address is going to be in Vietnam and it's going to require me $100 to send it in mail that's not going to take 3 months, you might have to wait a while. Or I'll charge you postage or something. I don't know. We had a postage question at the start of this talk. Okay, well, this was an all AA meeting. This like very, very useful. And, you know, if Theodore, if you can, you know, beat through what the failure success rate, I'd say Theodore, but anybody on how to do Approx the other way, I'd love to do it. Otherwise, I'm going to do Approx by taking one of these other approaches and not doing Approx.
I would try to think some kind of compromise between what you're doing, but eventually the more efficient, the more less cumbersome version would be to cut early of the type.
Yeah, well,
to
I tried to
approximate.
cut early, and then the cut early gets you to cut really early, really quickly, and that was the painful
Okay.
part, which you could try cut, and I could show you places where you surprisingly get a poor answer. So I'm going to try some of these other things. The plan B or plan C, I claim, look better. Like plan C is cut early, except also immediately meet upon thyself. So it doesn't cut to scalar or to bottom, it cuts to back onto yourself, and it's still using meet. So it can give you some reasonable good answers. So I think plan C is my current theory.
I'll try it.
I actually don't need oh yeah, okay. So from my theory side of pieces, for the plan C, I won't actually need a separate memory object because I don't have any side effects. So I'll get rid of the trivial global memory altogether, actually, for that one, and not deal with side effects. The core AA guy already tracks memory through and deals with side effects, and he naturally does this already. So I think the core AA will do nothing to get C done, basically, and Henry Milner needs to understand the C version of things, and then the plan C version, and then life will be good. That's my theory. I want life to be good. I like the look at the case statement there. I might need curlies somewhere. Not sure if I want curlies there or not, but it's the right kind of thing.
It does have the right things. It will require more fiddling with the syntax, but
I don't like indent only as a syntax. I want some positive syntax statement. Right now, curly is only used for functions, and at curly is only used for structure prototypes. So I'm getting away without curly having any other meanings. So I'm kind of like, maybe I don't actually, you know, maybe that actually works, actually, from a syntax point of view.
Kirk is asking, how does one get fall through?
You do not. So in the separate world of I want to do fall through things, like the number of times and places where I want to do fall through on switches has honestly been limited to I'm implementing parsers, old school recursive descent parsers with multiple parse token bits that fall from one to the next. I don't see a big use for fall through. So at the moment, this switch statement does not have fall through. Well, the reason,
as you can see, the only reason I use a switch statement is because it has fall through.
Yeah. Okay. Here I am basically doing pattern matching, and I'm excited to do pattern matching to break out the parts.
Right.
So it's not a switch.
Yeah, technically, it's a switch expression.
It's a switch expression. Yeah. Java would call this a switch expression, but many other languages would just claim it's a fucking.
Which I'm fundamentally against, anyways, because, like I said, the only reason you want to use it, it's because it's, you know, I'd rather use polymorphism in those cases. If I don't have fall through, then polymorphism is my choice. If there's a good fall through case, then yeah, then I'm inclined to use a switch statement. I don't think I use switch statements where I don't have fall through.
Well, you're using the fall through in a meaningful way.
In a meaningful way, exactly.
Yeah, okay.
Because other than that, without fall through, it's just a poor man's polymorphism.
Yeah. Well, right. Many of the algorithms I write, distributing the polymorphism among the many subclasses hides the nature of the algorithm. So I like this kind of poor man's polymorphism for certain kind of large, complicated things where the algorithm is simple, but it gets blown apart, not among cat and dog, but the 27 subclasses I have. It's hard to read the fucking algorithm.
Yeah, well,
so I go back and forth.
Probably it's hard to read the algorithm anyways.
Well, but it made it worse. You
can break it. Yeah, I don't know. I'm going to say you might be right for your use cases, but I've not seen it that way in anything I've done.
We
Okay,
can abuse as the syntax or
yeah, I'm looking at it. And cat colon is how I do type annotations of
Okay,
of a struct.
okay,
So
that's
that's a
fine.
name struct. There's a meow field. It's named as cat. So it requires you to be a cat, and you've just given a name to the meow field, which is fine.
Yeah, I've never quite grokked the pattern matching thing either, but it's very common, and I guess it's the only hammer that you have in functional programming.
If you don't do subclassing, then yeah, it's the hammer you have.
Well,
Type unions are basically subclassing for which you don't want to deal with making a class for everything, with this kind of a breakdown.
yeah, but it's actually, I mean, in the small that seems bad, but in the large that actually works better. One of the things that we've done in the application is just said, I'm not exposing these JDK classes and APIs and internal structures and things like that. Once you start doing that, you actually see huge wins in terms of the code and understandability, readability, and all kinds of other things, and you.
So say that again. You're not exposing what to the JDK APIs?
Oh, I'm internally in my model, I'm quickly switching to the language of the domain. I'm not passing around. I think I wrote about it in 97 things. I said, hey, Fred, can you pass me the hash map? Just doesn't make any sense, right? So I'm coming up with meaningful abstractions in the code that I'm writing, and a file tends not to be a meaningful abstraction in the model that I'm using. So I don't pass files around. I don't pass strings around because strings are not meaningful abstractions in the models that I'm using, right? And once you start getting away from these things and actually using meaningful abstractions, then I can better collect behavior, and I can generally end up with better, easier to understand, more meaningful algorithms in these cases.
Okay. Yeah, we can compare.
And so you don't expose these things, which means that, again, the only reason I'm going to use a switch statement is because because the fall through behavior for that particular case makes sense. Other than that, I'm going to naturally use polymorphism because that's just a part of the model.
Yeah. All right. So what I heard out of that was a request for some version of a switch with fall through, which doesn't necessarily match any of the case expressions. And I would typically use polymorphism, except in places where I have a tight constrained algorithm that needs a few special things done. Everyone's looking roughly the same, except for 5 guys. So I want to put right here, say these 5 guys are special, and I'm using case expression instead of.
That's fine, because if you use an interface in those cases, then you don't have to worry. It actually normalizes your workflow very nicely.
Okay, so this is a case where, of all the animals in the universe, cats and dogs are special, and everyone else hits the default answer, and I'm all happy.
Well, well, that's why I question your modeling in this case, because you have cat meow, which is actually tied. But if you have animal make sound, then I would expect it to emit a meow. I mean, it seems like a meaningless semantic,
totally.
gyration or whatever like that.
I'm on purpose picking different typed things that don't mix with each other, so that you're showcasing, you can talk about things that aren't common between cats and dogs.
Sure. Yeah.
Okay, and legs is the common thing, right? Okay, they make a sound, that's a common thing. Legs is a common thing. Meows have a volume, and tails have a wagging rate. And these are different units of measure or something stupid like that.
Yeah, and they have different ways of wagging tail.
Right. So when I do my real stuff with these subclassing, I typically have this kind of thing. Everyone who's common got commented up. Everyone who's subclassed has something special they do. In certain contexts, I'm really excited to talk about the special things this set of things does, and no one else does. And I don't want to put a type hierarchy in there. So I use
but then if you're talking about managing these special things that this thing does, then you're talking about a separate workflow to manage those things.
Yes.
Right.
Yes. And that's still
if you're going to normalize your workflow through, right, then you really are going to restrict yourself to talking about the common things that all of these things actually do, right? So that's the case for polymorphism.
Right. As soon as they're a common thing, it landed on the polymorphism side.
Right.
So I'm using both. That's what I'm saying.
So what I'm suggesting is that if you model in the business language, you tend to find that when you get rid of these technical classes and things like that, and go to like business domain classes, that you tend to find that you can normalize your flows a lot easier than if you start just,
you
know.
you are welcome to come look at, how to make the AA type system
Yeah,
a
sure.
better structure. I think you will find it is amazingly a complicated problem with a lot
I'm
of
just
subtle
suggesting it is.
algorithms.
No, I mean, the people
Type
who work with
systems
that
are
are
easy. They're trivial. Come on.
Yeah,
I
exactly.
mean, one question I think compilers actually as a business domain may show that the switch statement is a better way than polymorphism. What I'm thinking of in particular is think of your business language as being kind of operators. You may group them into a hierarchy, but you do not always want to override every single method. Sometimes you want a switch statement to cover every single arithmetic operation and do the exact same thing. Sometimes you want a subset, like the exact same thing for any binary operation, the exact same thing for any unary operation.
Yeah.
But sometimes you want to do exactly single thing per addition, per multiplication, per division. So I think that polymorphism as a subtyping works very well if you want to do one thing at a time. So if you want to override the method for addition, for subtraction, for multiplication, and on, then you are fine, and it's almost equivalent. But the moment you want to do something for a group for things, and you do not have a single hierarchy because your domain doesn't have a single hierarchy, then it's a better match to use a switch statement, because that fits
that's
the
your
logic.
modeling. That's your modeling. If you're modeling,
well, that's the world
singularity,
modeling.
you're true. But if you're modeling for multiplicity, then that argument falls apart. And again, that's, this is a bit bike shedding. If I go back to the code that I write, that's the practical code that actually ends out at the door, like what we did in GC Toolkit as an example. It's basically, polymorphism is been a much stronger tool and a much more useful tool than a switch statement in those cases. In that case, and that's generally been the case. But anyways,
I think there's room for both.
Oh yeah, absolutely, absolutely. I'm not saying there is, but one of the main reasons I use switch statement is fall through, because then I can group behavior.
In the LLVM, it does comes up. I mean, and that's my one regret, that C++ doesn't have pattern matching and forces you to use subtype polymorphism. Is exactly in LLVM when you often want to do this grouping. You often want to do some analysis only for the arithmetic.
When you say pattern matching, you mean, Matt, you specifically mean type hierarchy matching, right? Like, consider it's not a tree in C++, but it's close enough. So basically, you want to say,
I mean, I don't
match this point in the tree.
Pattern match it with exhaustiveness checks.
And we do a ton of pattern matching, right? In our model, right? It's and the pattern matching has actually been abstracted away from the main flows.
So Kirk, I have a question about your fall through, because you said a different thing. You said I use it to do grouping of things that I want to do similar behaviors to.
Well, if I want to treat something, if I need to treats, a couple of cases the same, right? But
right. As soon as you say a couple cases the same, that just is a case syntax where I would do, like in this case, I would say horse and pony and camel, arrow to, whatever, animal dot, run speed or something. Yeah, where I've grouped a bunch of things that are the same type.
Yeah, throw a car in there.
Yeah, a car can be in there.
Yeah, of course.
A car might have a run speed.
Because it has a speed also, right?
As long as it has a run speed field, then this works.
Yeah, exactly.
So this is not fall through yet. Fall through says I had some behavior. Some other folks get there's a stack of behaviors where some early
it's a
guys.
Stack of behaviors. Yeah, exactly. Fall through is there is a stack of behaviors.
Okay, and you want the stack of behaviors.
Different entry points in for each of the behaviors.
Yeah. So you want the stack of behaviors is what I just heard you said.
Yeah, exactly.
Okay, so this is the classic one where E0 happens, and then case 1, E1, and I'll put a comment here. Oops, another dot. There we go. Google gets done. Worth time, my come on. There we go. Maybe yes, something like this. Okay. Three, and then dot, I'll go should stop already. Break. Yeah, break gate. Okay, in case 4, dot, dot, dot. Okay, so what I'm doing here is just saying you actually do want the partial stack behavior.
Right. And maybe after case 2, I want to do something before I hit case 3.
Well, that's what E2 is.
No. Okay.
Right. So, and this is all of E0 through E3, and case 4 has an E4, which is unrelated.
Yeah. Okay. Yeah.
Okay, fine. Fair enough. Like I said, I rarely use this behavior. It shows up in my code from time to time. I could always work around it, but I can understand that there's a broad use case. And I certainly have some very specialized use cases around parsers where I get this sort of in spades, where I'm looking for ranges of characters to break out to different classes of things right away.
Yeah.
Okay, fine. But that's a very specialized version of things. Yeah, here's somebody doing Duff's device, which is exactly the case. Yes.
Yeah, there you go.
Okay, so there is at least some call to support fall through in a meaningful way. And this is switch. So here's instance of.
I mean, if that's not important to the people you're targeting, then.
I don't have that kind of a target audience figured out yet, so it's not crucial left or right. Like this is a case where you can easily write obfuscated code, but your notion of I have a tower of things to be done to succeeding guys is not an unheard of concept. It's just less rare. Like I'll do this with an instance test. Oh, don't do continues there for person whoever's adding. Add a new field. Don't break E0 up. Oh, you're trying to add a keyword to say fall through is okay.
Yeah.
We made it explicit because otherwise.
Yeah, right. Oh, I hate that keyword in that context. But
yeah,
always use continue. Go backwards to the prior outer loop, not go forwards.
Say again.
Continue means for me just intuitively. Continue
go back to the top and it's a loop construct, right?
It's a loop construct. Go back to the head of the loop you're in.
Yeah.
Go backwards branch, not forwards branch.
Yeah.
So I would say continue is the wrong keyword here. A keyword might make sense.
That's a weird take because continue, say in a 3-part 4, continue continues to the 3rd part. That's what continue does.
I understand the English language meaning of continue. I have the C language meaning of continue.
Continue, that's different.
Baked into my brain.
Yeah.
So I claim a weirdness issue. You're changing the programmer understood meaning of continue, not the English meaning of continue.
Well, and again, switch statement also does that to my brain too, because you have a C definition of what switch is that's transferred to just about every other language on the planet, right?
Yes. Java.
So now we're doing something completely different and unexpected with the same structure.
Right, which is kind of why I used case instead of switch in the pattern match above, as I didn't want to claim you're a switch statement.
Yeah. Well, maybe that's it. Maybe you just use switch and case.
The pattern matching becomes a pattern matching when you add the classes in a hierarchy and it's destruction, as I tried to show. This is matching the cat type as well as bounding some, because we have a type defined here. It can be anything. It just doesn't be a. That means
No, I would claim meow matches a field named meow, and you're just pulling the field of animal.meow out into a variable called meow. If you put an arbitrary name in there, I don't want that to mean all of the contents of cat with it being inside the curlies.
Okay.
If I want to have it outside the curlies, it's already outside with the word animal, which just got tagged as a cat.
Okay, that still counts as a structural matching.
Yeah, it's a structural match. Yeah. You were trying to change what you wrote inside the curlies, and I was
okay. That's fine. That's fine. You because you have to bound automatically the names you have defined here.
Yeah,
You
right,
can
right.
escape. Okay, that's fine. That's also fine. So my point is the pattern matching becomes a pattern matching when it's a switch statement and supports the class hierarchies and some syntax and some instruments to inspect the class hierarchies. That's, at least to me, becomes a pattern matching.
Okay, I mean, I'm not, I mean, as far as I'm concerned, the pattern match and the switch are two orthogonal different ways to make some choices. I have a thing I want to make some choices on. They have different uses in different places.
But the switches, let's say in Java, doesn't yet support the classes. And
I'm using the class version and I hit the evil preview, don't print the fucking preview warning flag. But I'm using previews on Java 17 now, and it's kind of nice. The places where it shows up, and when it shows up, it's kind of nice. So this is in Java 17 preview.
That's fine.
I think a little different, of course, as I did some of the syntaxes AA style instead of Java style. And he can't do the legs as a general anybody with legs. He'll only do classes.
Mm-hmm. Yeah,
and he applies them the tests in order, so it's not a Huffman encoded tree. It's an in order thing.
That's the pattern comes at least to me because it has to be a pattern. It's not just values, but it's a pattern.
Right.
Yeah.
Well, that's your dog : wag rate is a pattern.
Yep.
My legs example.
Yep. Yep. The thing that is missing, let's say from Scala, is bound. You can bound, let's say, some kind. You bound the animal to be one of these types, and you use it in the right hand side, because it have to come from somewhere.
Okay, don't. That's the wrong syntax, so I don't want to do that one.
Okay.
So all that happens is that the right hand side of the arrow there, animal has to be one of horse, pony, camel, car.
Okay, but where animal from?
All have to have a run speed field, or it's invalid. But they could be otherwise unrelated, other than they have a run. There's no hierarchy there.
Okay, that's fine. Animal, where animal should come from?
That's from the word case right here.
Case. Fine. Okay, I missed that. That would work. Okay.
So that only works if you have a single variable, which I could then take that variable and upcast it.
You will refine the animal with this. Okay.
Right. And that's exactly what happens here in an if, where the animal variable is refined or the true. Same thing happens for null checking. If I null check animal on the question mark side, it's been refined to be not the null.
Most of the pattern matching cases should be destructed into if-else cases. It's just a nicer syntax.
Right. This all destructs into an if-else tree. Right. And then, that's the partial, just like I said, just needs partial love. Everything else is in there already.
Okay. With the very few cases, the pattern matching should disappear. It's just a nicer way to structure the code.
Yeah, syntactic sugar all the way. So the other comment here is that if I do a general expression instead of animal, you don't get the upcasted flavor because the general expression can't itself be given the casted value. You don't have a name for the general expression in the right-hand side of the arrow. But in AA, you can do temps anywhere you like. So you can just assign the expression to a temp and then get it on the right-hand side. But there is a deal there. If you replace animal with some arbitrary complicated expression in the case of horrible thing.
That is the problem. That is the strength of the pattern matching, and is the problem because it can be anything, and you have to come up with a way to express.
Okay. Well, I'm claiming 12:30, 2.5 hours. Been a good walkthrough.
That was interesting discussion, at least to me. I will buy a t-shirt. I will send you an address.
Send me an email because I'm going to collect the mail so I can keep a count.
Okay.
And then we'll debate what we want to do it from there.
Cool.
And if I don't hit the quorum, you just won't hear anything from me.
Okay. Next time.
Yep. All right. Till next time.
Bye.
Bye.